Understand a numerical problem which will enhance our understanding of resistivity of a material, of a conductor, resistivity of a conductor. It's denoted by rho. The question is saying a wire of given material is a material. We don't know the material. It may be a metal, any metal, of any, let it be any metal, a material having length L, and the material has length L. The wire has length L, and the area of cross section. The wire, suppose if this is the wire, the length is L, and if this is area of cross section, the area of the cross section is A. And now this, for this particular material, there is the resistance of the material is 4 ohm. I just want you to understand the meaning of 4 ohm, right? For 4 ohm resistance is what? According to Ohm's law is V by I. So 4 ohm means for that particular material, if you if there is a potential difference, if you are able to maintain a potential difference of 4 volts, and because of potential difference of 4, potential difference V, and then because of that some electric current I will flow, the ratio of that potential difference to the electric current will be 4. This is what the 4 ohm means. I want you to know this. 4 ohm, it's the ratio of the potential difference maintained and the corresponding current that will flow through it, through the material will be 4. That's why the resistance is 4 ohm. The question is saying what would be the resistance of another wire of the same material. Now you are taking another wire with the same material or the same kind of same metal, but here what is happening, the length will be L by 2. You will reduce, the length was this earlier, the length will be half, it will be L by 2, and the area of cross section, this area of cross section will be double, twice of A. What was initially A, it will become double, area of cross section will be double, and the length will be lessened, right? So what is the relationship between the resistance of a material, its length, and the area of cross section? The relationship is resistance R is equal to rho L by A, where rho is the is known as resistivity of the material at that particular temperature. There should be some particular temperature. They have not mentioned temperature, but temperature should be maintained constant, so that rho or resistivity of the material remains constant. So since they are having the same material, their resistivity will be same. So for the initial case, the resistance is how much? 4 ohm. It's given, right? Well, when the length is L and the area cross section is A, let rho be the resistivity. We don't need to know the rho because it won't be needed. Let's see how. Now we are required to calculate the new resistance R1, right? How it will be done? The resistivity, it will have the same resistivity into multiplied by length upon area cross section. Let the new length be L1 and let the new area of cross section be A1. So what will the new length L1? It will be half of L, that is L by 2. It's given by the question, right? And what will be the new cross section area? Will be 2 times of the earlier cross section area A, is twice A. Simplify it, what do you get? There's 2 below this, 2 will come as a denominator, that means 1 by 4. And what remains? Rho remains, the length remains, and A. Rho L by A is what? It's the original resistance given, that is 4 ohm. So replace it by 4. So 1 by 4 multiplied by 4 is how much? It is 1 ohm. So the resistance of the new conductor of the same material with length half and area cross section double would be 1 ohm. See, you can see like this also. See, resistance is what? It's inversely proportional to area. If the area becomes more, that portion becomes more, its resistance will decrease, right? In this case, the resistance the area cross section has increased, so resistance will decrease. It will be less than 4 ohms. And in addition to that, what happened to length? See, resistance is proportional to length. What happened to length? Length has half. The length has half means resistance will be half, or it will decrease. So that in both the cases, what has happened is it has made the resistance lesser. How much lesser? It was earlier a 4 ohm. Now it will be 1 by 4th of the whatever earlier resistance it was. So 1 by 4th of 4 is how much? 1 by 4th of 4 is 1. So the new resistance will be 1 ohm. Hope you understand this.